project of improving analysis at CMS experiments. Nowadays, I'm working in more focused in the VBF part, but yeah, I will present all the projects for you. Uh, it is divided in two parts, the luminosity estimation and the VBF part. Basically, my supervisors are Christina and Carsten, as mentioned before. Yeah, considering that I have a small line here, giving you a little introduction about my work. I have the luminosity part, the luminosity estimation, considering the zinc counting method. I will talk just about the golden part, it is the offline part. And I basically work in the inclusive, considering barrel and handicap, and barrel only, and handicap, but handicap will probably no add because there are not so much information. We can extract more considering the inclusive and the barrier part. Considering the BSM models, we start with the magnetic monopoles. I will talk a little about the ionized particles, signal efficiencies, a little about the cut flow, how to we work with that. The ABCD methods I don't talk today because it is too much for today, but yeah, considering the dark photons part, we have the VVF triggers part, the kinematic properties, signal efficiency, and all of the projects considering the VBF part, it is more focused in the electrons with low PT. Yeah, in the final part, it is the SUSY compressed spectra. I believe this is the order, but yeah, the VVF part, it is in the final of this presentation. Yeah, and for SUSY, we have some signal yields to discuss as well. Okay, I will do that in CMS experiment at the moment. Basically, CMS have similarities with the Atlas experiment. Yeah, you have some difference, but uh, the projects follow basically the similar ideas because I was talking about considering the luminosity part with the muons. The magnetic monopoles are more focused in the photon trigger and the uh, I yeah, lost the order. And the dark photons are more focused in the electrons part. Basically, we need all the detectors to understood how to we can work with that particles. My thesis is focused in the complete proposal to understood the particles and have more idea how to work with different particles and yeah, how to work in CMS as well. Considering the luminosity estimation, it is a project that I'd like to work since my master, but I have an opportunity just now. Basically, this model, this method, we can work in the luminosity estimation with the number of Z bosons divided by the fiducial cross section, but the number of Z bosons obvious is reduced considering the fakes. We have some fakes in the BIOS part, but we work with the Z in the meal mais and meal menos, and yes, this saúde. But this we have here a clear experimental signature and large cross section to working on. The fiducial phase space, basically, we work in the dry ion process with muons without intermediates. The ZPQ region is estimated in that part, and we have a muon acceptance considering 2.4 and PT to 27 GeV. We work in the online luminosity and offline luminosity. I will just share the offline one because it is my part. And the luminosity, the main difference between that ones, it is the offline luminosity is a little better because you have more time to working on that, to have more procedures. And the online luminosity is more the online luminosity is more fast, but the efficiency is not so good. Basically, we're talking to you about the run tree analysis. I will share here the 2004 inclusive and barrel results. Here we have my contributions, considering that part. When I start this project, we don't have the main the chain automatized. We basically have a deep note in the beginning of my PhD. Considering that project, it is the main contribution for that project. And yeah, this DP notes, we talked a little about the 2022, but we have some kind of improvement. Nowadays, we have a little more than that, but basically, we have the DKM part for produce the histograms. Following that, we have the harvest part to manipulate the histograms and have and produce a CSV to the final part, have on the website and all results organized, considering offline part and online part, and we basically compare that to understood if everything works well. Yes, basically that's for this slide. Yeah. Basically, here we have the meal identification, and it is factorized in three parts. We have the global, standalone, and the tracker part. We identify two muons with opposite charge. If you identify just one muon, fire the trigger, you follow the N1 equation. And if the both muons fire the trigger, we follow the second one. We basically fit the environment, the invariant muon mass. I don't show you in that presentation because it's too much, but we basically fit that. And these results, it is performed in 20 minutes. Here we have the delivery luminosity considering the LHC field 10001. Here we have a comparison between the golden and for barrel and inclusive. Here we don't see so much difference. We see a very good agreement between the reference luminosity and the Z rate. Basically, we have not so much difference between the inclusive part and the barrel part. The difference is so small. And for the next slides, I don't present the difference between both. Basically, we present the inclusive part for the inclusive part considering barrel and edge cap together. Yeah, considering this slide, we have the global muon efficiency and the identification muon efficiency and the standalone muon efficiency. All these efficiency are have a flat distribution, and you don't see so much difference considering considering the time dependence. And considering the pileup as well, we don't see so much difference. But when we see the HLT, we saw the HLT have some kind of dependence considering the time and considering the pileup. In this plot, in the specific one, there are not so much dependence, but yeah, in your other fields, we can see a little more decreasement with the pileup for the black one. The final part, basically the stability results. Here we have stability results very, very close to 1, and we expected that. Yeah, basically here we have the integrated luminosity considering the Z rates and the half lumi. And yeah, we expected these results, and this is the middle of the run. We have the beginning part and the final part to add and complete everything. Considering my final thesis, I will probably combine everything, but yeah, at this result we have just 24, but not the complete run. we have just one part, but yeah, the final I intend to add more details considering that. Now we have the beyond standard models, magnetic monopoles. Here we basically consider the Dirac magnetic monopoles, and in the collider we will work with ionized particles. Ionized particles are basically detected by ionization, and we will expect something good in the tracker or in the calorimeter parts. And for CMS and Atlas, we can see in the plots on the right. We have a smaller contribution when we saw LSM without have a little more. And yeah, we are not in the advantage considering the statistical part, but yeah, we are in the game. You can and understood how we can do with few events. Yeah, basically this particle is dominated by ionization, and we will study that considering the EDX variable. Here we have the magnetic monopoles Monte Carlo samples. I work with 2018 and 2016. I don't generate that samples, but I basically work on that to understood how we can proceed with that analysis. I work in the beginning of that analysis, and these Monte Carlo samples are generated with this chain, and we will generate basically a ionized track and expect strip deposits in the cluster, and apply some techniques to understood if we have some kind of deposits in the AgCal part. Considering my contributions, I basically compared two implementations in the beginning of this project. We have two different codes. The first one, it is monoanalyzer photon. We have this kind of output, but the trigger is applied correctly, but we don't have all the chain. The chains a little different when we compare mono analyzer photo and any tuple analyzer. We saw some kind of difference considering the cuts applied, and the strategy for the both codes is a little different. The main idea is combine these two codes and produce the analysis in one just one code. Here we have the trigger implementation validation. We have the cut flow differences tested. We evaluate the number of candidates and the number of events because the codes have different strategies. You try to understand what is the best strategy to follow. And one of the codes have the geometric inclusion, and the other one don't have this geometric inclusion. And basically, in the final of the process, we have we understood we have some kind of difference, but yeah, basically this difference it is considering the geometric part. I don't present this part today, but yeah, in the final of my projects, I intend to work on that. And yeah, the difference of the cut flow was evident here, but yeah, in the we try to fix that to working in this process. Basically, here we have the variables we have in the beginning, but these variables are without the cuts. We have E55 considering the energy deposition in the cal cells. F51, the X it is the more important one because we can understood about the ionization, and the eta is very uh, it's not too close for the barrel and not too extend for the end caps. And yeah, but magnetic monopole have some kind of plurality considering it. Basically, here we will work with quality cuts. We have a circular fit to work with D0 and phi0. A parabola fit considering three other parameters, and the matching part, it is the part I will present in the final of the project, considering the delta R and the isolation in the hadronic part, hadronic calorimeter. For this trigger here, we basically use the trigger of the photons. It is a trigger, was important to the beginning, but nowadays other trigger is utilized because the distracted it was not too efficient in the final of the process. And the final discriminant variables, it is related to higher cuts and the loose cuts. Considering that we have my contribution for this work, we have the difference of the candidates and events. One of the codes presents events as the mean feature, and the other one the candidates. Here in this plot, we saw the number of candidates were more interesting to work with this analysis, and we'll continue with that strategy for the other steps of the analysis. And basically here we prove that because we see a clear evidence the candidates have more signal efficiency in the final of the process. Here we have the cut flow, considering all the results, consider the rest variables, and with the application of the cuts here, but the trigger, the more it is the responsible for the efficiency, the final process of the efficiency. Basically, the trigger cuts a lot of events, and yeah, are responsible for the lower efficiency. And when we apply the GMAT, it is more lower than that, but yeah. Here we have the trigger as the main responsible for this lower efficiency. Considering the 2018 and 2016 in this plot in the bottom right, there are not so much difference between the beginning of the distribution, but in the final, we just work with the 2018 events. We have this kind of difference between the ranges, but yeah, the strategy is similar, and yeah, we have similarities with the the trigger application following the cut through part. Yeah, for the conclusions, we have a good strategy considering the candidates. The idea it is continually talking about the cut flow part. This analysis will more advanced at the moment with other persons. But yeah, this is my contribution how I work in the beginning of this analysis. It is one of my favorites, but yeah, uh, for the next steps, I will talking about the GMAT. It is my intention. But if I don't talk about that, this is my contribution considering the candidate page parts and the events comparison. Yeah, now we go to VBF part, considering the SUS compressed spectra and dark photo analysis. Here we have two different models. Considering the dark photon part, we have a note being right at the moment, ISO 25020. And the compressed spectra, it is in the beginning of the process to understood what is the better strategy to continue if this analysis is good to continue, and it's so on. Here, this analysis is just possible because the trigger, the parking trigger for VBF, this parking trigger giving us opportunity to understood about the electrons with low PT. The idea of using VBF in this VBF as a requirement, it is because the VBF work with the both jets and give the electron the opportunity to be free and appears more in the low PT region. That is the main contribution of the VBF, and the main reason I really believe of this channel. It is important to continue this both analysis. But in the dark photon analysis, I believe there are more interesting things to talk, considering that, because the dark photon giving us the electrons in more strategical way. Okay. Considering that, we have the dark photon candidate, basically VBF topology, passed by VBF pocket integers, goes to soft electrons, understood how the soft electrons could be identified. In the final of the process, we have the dark photon reconstruction. But in the SUSY part, we have the VBF topology, the VBF pocket trigger, soft leptons, plus the match part. In the match part, it is more challenging to be sure what will happen. Because of that, the dark photo analysis is my favorite, considering the VBF part. But the both strategies is very interesting, and I'm very passionate to talking about that. Okay, considering the SUSY part, we have two different strategies in my group. We have the inclusive analysis at the moment. This inclusive analysis is very advanced in one note. I'm not participating that, but it's very advanced. These inclusive analyses are focused in ISR jets, but we have for the jet topology, we have central contribution, maths and soft muons, and the final signature. We need to understood the maths and how the match work with the soft leptons. The match contribution could add some different things, but in this analysis, we try to understood how better contribution. But when you talking about muons, is a little more easy in CMS than when talking about electrons. But it's similar in Atlas. We have challenges when we work with electrons, but it is very interesting. Considering the VBF part, we have two forward jets, and it is the main idea of this analysis. The two forward jets with back and forward jet is very easy to identify. But the main idea here it is give the electrons the opportunity to be more free and understood how we can go in more the PT is down, how we can study when the PT is 1 GeV 0.5 y understood how it is the challenges, considering our resolution, and how the detector lines when it goes down, and understood how is the way to try or deal with these electrons. Basically, VBF have big and important contribution, because these electrons are more free and goes down more. We can go down with the PT more frequently than the ISR part, and this is the main idea of the use of VBF. Here we have a little about my contribution. Basically, try to understand the charging neutral linear contribution, considering the SUSY part. I simulated that chain in the final of the process, the pre-processor and the pro-processor, the post-processor. In the final of this chain, we have a skin part and SOS3. It is produced. I basically work in this process and eliminate the match contribution who had in the other analysis. Try to understood how we can better work with the match contributions, considering the VBF part. Basically, we have the technique. This name is it is a little complicated, but the KWZ, considering the mass of electric kilos, 2000, and the 5 and 10 for the delta M part, we have an inclusive and the vector Boswell fusions samples for that part. It will be basically reweighted for the 2018. The main idea here it is talking about the MET in the gen level and the rec level, and try to understand how to work with the PF MET and the PUP MET contributions. As I said before, I basically have an event scheme, SOS event schemer. These details from my analysis, but in my study, I basically remove that cut and try to understand what's best what's passive, what's not, and how to work with the other loose leptons in the final of the process. But yeah, here I will not present the part of the trigger for the SUSY part, but basically here we put the PF maths without these requirements, and there are no requirements for the number of jets. Try to integrating better with the trigger part. Here we have basically summarizing the Monte Carlo samples, pass for VBF and inclusive topologies, try to understand the meta studies. After that, you have the yields studies and a little about the physics interpretation. For the ISR, follow the inclusive part, we basically, as the HC, try to approximate the both analysis, the VBF part and the inclusive analysis, because we have a different, in the next slide, we saw the difference between the statistical part. Here we use selection criteria for the jet part, considering eta, PT, and the jet ID. Here we can saw the inclusive distributions, and that it is the original ones without the AT contribution. But when we add that, you have a boost. We have a shift for the right part. When we have these shifts, it's very, very interesting to compare VBF and inclusive. Here we have VBF and inclusive and inclusive with AT. And in the bottom part, we have the VBF and inclusive with AT. But we saw here the VBF part, the VBF inclusion have minus statistics, considering the inclusive analysis. And what VBF could add for that for the inclusive, considering that our question it is what the region we can improve VBF with the VBF analysis. Basically, when we work with the PUP match, it is the match with minus with other requirements, considering we have the PUP mat and the PF mat, and the PF mat have a strategy considering the particle flow particles, and the PUP mat have more additional contributions to reduce a little the number of events, but improve the quality. Here we saw the VBF have more advantages in the small part, because when we saw the small part, we saw we have the middle of the events are continuing here. And yeah, that's the main contribution of the VBF part, because here we continue with the 50% of the events. And that's the best strategy for VBF, not considering increase of 20, but the decrease part. Yes. Okay, yeah. For this part, we have the inclusive and the comparison between the VBF and inclusive production. And we saw ACR have a requirement about 20%. And for the VBF, the main idea is a lot of events survive when we stay in that region. And because of that, this strategy is very interesting, but have limitations considering the trigger part. And the next steps of this work is talking about a little more about that and try to understand the trigger application. Next slide, it is considering the dark photo analysis. We have similar strategy considering inclusive and VBF. This one is very, very interesting because here we don't have mats and yeah, the electrodes are more free to understand how down we can go in the PT and how to understood how the electrons are able to be identified at CMS experiment. Basically, you continue with BBF trigger, parking, similar strategy for SUSY, but here we don't study METs, and that's the main advantage of this analysis. Yeah. Here we have our strategy at CMS. We basically saw CMS have this kind of contribution, and we try to simulate our samples considering this region. But the idea of VBF, it is have more clear signatures and understood how down we can go to identify that electrons and try to understood if the dark photon appears or not. That's the first samples we generated at the beginning, and here we can see a difference of the statistical difference, as I said at the beginning, but VBF have more clear signatures and have the opportunity to identify electrons more down, and yeah, that's the idea of this analysis, and that's I'm focused at the moment. We basically use the configuration of two jets at the beginning, using PT with these requirements and MJJA and the other ones with that. But nowadays we are working with new samples. We have new requirements and new statisticals to working on. But this is a work in progress, and I don't have the main updated samples here, but here we can understood a little bit how the kinematics works, and we have basically PT in the smaller than 20, and it's very, very interesting for the electrons leading, sub-leading. And for there are not so much difference between inclusive and VBF, but we can see more clearly difference in VBF than in the inclusive part, because in inclusive we have similarities. There are not so much dependency considering the mass, but in VBF you can saw something different and try to understood that will be very, very interesting. Nowadays we have more masses, and the last plot is more updated than these ones. But yeah, considering the inclusive, it is interesting understood we have the trigger focused in the barrier part, and the VBF distribution, we have the handicaps more in focus. Try to understood about the delta R, considering the inclusive part, we saw particles with smaller masses, more collimated, and the VBF all of the masses are correlated, and how to understand that there is my focus in the last 5 or more years. But I don't have so much opportunity to work on that. But it is something I'd like to work on. Yeah, that's the last plot I will show with you today. I'm not sure about the time, but I believe I'm in time. Uh, this is the most updated plots we have at the moment. We are working in ability and a multivariate ID, try to understand how we can go down to PT and how we can separate electrons from the signal and electrons not from the signal. And our ability at the moment to give these results is very, very interesting. But more things I need to work with that. So this plot for me is very, very fascinating and very, very interesting. Yeah. Nowadays we have a clear separation, but there are so much things to be done in this work. And I'm very, very grateful to work on that. Yeah. In the final part, basically that's I said before. We have interesting samples to working on, and the idea of this analysis is continuing understood how the BDT work to improve the ID requirements, and yeah, there are so much things to be done, but yeah, this is very, very interesting analysis. Thank you so much, all of you. That's my point of views.
Thank you, Mariana. Thank you for this nice presentation. I think we can jump right into the questions and answers. Maria Silvia, do you want to start?
Yes. Thanks, Mariana, for this very comprehensive presentation. There is a lot of work. So just for my education, that is a question that I really want to have a perspective what you are going to focus now in terms of your beyond the standard model search, because there is a lot of in common among them. And we know how demanding is to deploy an analysis. So you don't need to give me a complete answer now, but I mean, if you would have to pick one of them to finish your PhD, which one is your choice?
Today,
based on the analysis
today probably the dark photos, because the dark photos are more fascinating. The subtitle I had, the dark photons have a big opportunity for the future. Yeah, the FCC, there are a lot of things to be done. Yeah, if I pick today, I will choose the dark photons. I'm very passionate for the monopoles part, but yeah, if I choose today, I will work with the dark photo analysis.
Okay. So now, can you please go back to the beginning of your presentation? I think it's better if I go through the sequence of slides. We can get started with the Z counting method. Okay. I think that's, you can go to slide 6 or 7. Okay, this one's okay. I think we can stop here. First, out of curiosity, because this is, we know this is always related to reference runs and reference fields for the LHC, but do you know the reason for this particular field that was chosen?
I choose this one, but in general, I present three different fields in the beginning of the run, in the middle of the run, in the final of the run. And we try to understand if we have similar shapes and if everything, if the reference is very agreeable with this tree. In general, I present more than one field, but here will be a little too much for presenting time. Yes, it is too much.
Yeah, because there's this nice profile of the luminosity, right?
I choose this one. I choose this one. But yeah, there are others examples with similarities. But in general, I present three to compare and with if the people saw and yes, okay, this is our working well.
Okay, so thinking about the Z counting method, okay, if I understood it correctly, in terms of your proposition for the thesis, you defended that this is it's presented as an independent it's an independent method, but not a substitute for the van der Meer scan calibration, right? Because that's what
Yeah,
we use as, let's say, the official
yeah, the Van der Meer, I'd like to study it a little more. I saw that there are some weeks ago with more attention. I basically work with that the Zikauti method, and I feel it's very good to do that. But the Van der Meer give an opportunity to go if other way. But I need to go is more profound to understand that. At the moment, I don't have this answer.
Oh, I see. So now looking at the Z counting method, which what is the dominant source of systematic uncertainty, for example, to evaluate it more precisely in this approach? What is the source of systematic uncertainty that is more, let's say, more important? Is it acceptance, efficiency of the modeling? How would you
I believe the millions, choose millions is the best option. There are nothing better than millions, because CMS at the moment have the best strategy for millions. Work with millions and millions are easily to identified. But if I have opportunity and more time, I probably will work with electrons to understood. That's different. In numbers, I don't have this answer too, but at the moment, the muons strategies have the better contribution. But when we saw the Z as a branch rate of the Z, when we saw that, we saw the muons are just 10%, and yeah.
And you don't have to compare it quantitatively, but qualitatively, do you have an estimate on how this compares to the van der Meer scan method, qualitatively speaking?
At the moment, no. At the moment, no. I need to be more profound.
Maybe that's a good thing for you to add later in your thesis, because
yeah, I believe that.
Comparison. I know you are not proposing to substitute to the traditional van der Meer scan.
It is something I'd like to check. I don't know if I had time.
Okay.
I don't know if I had time, but it is something. It is not a promise. It's not a promise, but it is something I'm have curiosity. It is something I have curiosity to understand the yes how it works. I don't have so much opportunity to do that, but if I had, yeah,
I
it
see.
is something I'd like to check.
I think we can move on a little bit. Let's go now to the analysis. Okay, you can move on. Yeah, then this, I mean, this last plot you show in terms of stability, I think this is something more in the path of qualitatively speaking. You prove that the method is accurate, but then my suggestion stays. So if you could do, and if you have time somewhere, it would be nice to consolidate the work, because it's a lot of work here, right? Okay, now let's go to the experimental strategy of the analysis. Okay, so you can move on. Next slide. Oh, okay. Here I have a question. Can you please go back? Oh, that's something I was wondering, because that's something I missed in your text about the Monte Carlo settings that you had for each one of your beyond standard model searches. But then here you provided a mass grid. And then you just mentioned here the difference in terms of mass points that you are searching. So is there any particular reason for this first set of mass points? It's based on what in terms of model?
It is a test.
Practical input for this mass range. I missed this during
Considering the dark photons part and the SUS, it is more easy to understood, I believe. But here, it is more tests. I believe there are no, at the moment, I don't remember the reason of that mass points are chosen. But the first strategies have mass points in the down part, and maybe this is not working well. But the both documentations I had at the beginning are completely different, because one strategy is more focused in the candidates and the other events. It is difficult to concatenate and understood what is the best one. What I know at the moment is the first person working the beginning part and have these kind of values, but maybe it's not good and not interesting. There are one note in the wrong one. I don't mention that here, but there are one note in the wrong one. I don't remember now the numbers because it's too much information for my head. But yeah, the first person working that part, and the second one try to understood more the range in the final of the distribution.
Because naively, I would expect the mass range to go really beyond the 2000 GeV. So I just wanted to see.
I expected something that, because we are working with high ionized particles, and yeah, if I go to that way, I expected something more, something bigger. But as I'm fascinated for the small part, I'm always will check if there are something interesting the small too. But yeah, here is basically when I'm checking both codes, and the strategy is completely different. It is difficult to estimate why for me at the moment, but it's something I can answer the next period. Try to understand better that and be more focused on that.
Could you please go to the next slide? Okay, you can move on. Because this is clear what you did in terms of the strategy. So, okay. And then I think in terms of the variables you chose for the distributions, I think it's well defined in the text. So I have no questions regarding this. Essentially, you're using a shower shape variable. So I think this is nice. And then you can move on. Okay, you can move on. Okay, so here, okay, this is for my understanding here. So essentially what you're comparing here is the simulation you had considering run two results, right? Because you are considering here center of mass collision energy of 13 TeV, right? So considering that at the beginning of your text, you mentioned that you would focus on run 3.
Okay, for the other part, but
Yeah.
okay. It is confused. Yeah.
How would this Monte Carlo, I mean, because if I understood, now you would need to produce the Monte Carlo for another center of mass.
No, for this analysis, this is the only analysis I work in the run 2. For the other ones,
Okay.
it is in the run 3. The other ones is only accessible in the run 3 part.
Okay.
This one, no.
Oh, it's clear. Okay.
No, it's more, it's confused. Yeah. Sorry.
Yeah, because then maybe it would be interesting to add a little bit more. I know this is a qualification text, but then I was wondering the level of the calculations in terms of theoretical predictions, how the cross section for this process stand. Just want to.
I will check if I had that information.
So that I could start to being more precise about my questions in terms of your cut flow strategy here. Okay, but I know this is a qualification text, so you can go on. Okay, you can move on. Oh, okay. Now for these models, I essentially put here a couple of questions regarding the experimental strategy. So when I look at you can move on. I am going to put together two of your sessions, which are, let me go back here, sessions 5.1 and 5.2 and 3. It's all together somehow.
Could you talking about the titles, because I don't remember. It is too much information for me.
Of course.
1 minute.
So
no, give me the title.
For the dark photon analysis, then you mentioned that the results for the massive dark photons at CMS.
Yeah, okay.
The methodology for the SUSY compressed mass spectra. So I'm going to put this all together. Okay?
Okay.
In terms of analysis strategy.
In terms of analysis strategy, the difference between the SUSY compressed spectra and the dark photon analysis, it is SUSY have a MET included, and this MET could be different particles and add this kind of information. The dark photons are more clear, and when we work with VBF part, we are more clear than the clear to understand the electrons. And yeah, the focusing in electrons, that strategy for the dark photons is the more clear one. Yeah, the idea in terms of the colliders, it is that. Yeah.
Okay, here, Mariana, when you mention the VBF trigger path in the analysis strategy, right? I think if I understood it correctly, it's let's say it's largely agnostic to the dielectron pair, which is what allows soft electrons to pass, right? So what is the actual trigger logic here? Does the HLT path fire purely on the forward jet topology? I mean, on your BBF tagging jets, with no electron lag at all in the trigger? Or is there still some minimal electron requirement at the trigger level? So this matters, I think, from my understanding, because it determines whether the low PT electron sensitivity comes entirely from the offline reconstruction or from a genuine electron blind trigger. Do you know what I mean?
Yeah. But yeah, at the moment, without dedicated triggers, the idea it is the electron continue free, or the requirements are just for the jets. We have MJJ, J1, J2, basically that, and forward jets.
Okay.
Forward jets, there are no so much to say, because forward jets are forward jets. And try to understand how the electrons orbiting that. The main challenge is the electron stay inside of the jets. That's something I'd like to study, but I'm not sure if in this thesis.
In terms of BBF selection, well, since you are probing this very extreme phase space, if I am not mistaken, we can check this in the next slides, but for the transverse momentum of the leading jet, you required a cutting 100 GeV, right? Then for the subleading 400 GeV, and for the VBF tagging jets invariant mass greater than 1 GeV, right? 1000 GeV, something like that, right?
Yes,
okay.
Yes.
But the electron PT threshold is down to 0.5 GeV.
Yes, this one it
How?
is this strategy.
How these specific thresholds were chosen? I mean, did you inherit them directly from CMS VBF trigger menus, or you applied an optimization by yourself?
If I choose by myself,
for this dark box.
This is not chosen by me, but if I choose by myself, I will probably add the same. When I studying my master, I go to 0.7 and it was good, but the detector have a lot of limitations, and yeah, if I choose by myself, I will choose probably the same 0.5 at the moment. It is a minimum PT to study, but go is down. We can go, but maybe it's not a good idea.
Yeah, because looking here, for example, I was wondering if you possibly could perform like a scan done to check, for example, if you lose your MJJ or the PT cuts, and if you do that, if you could recover additional soft electron acceptance without increasing your background. For example, just perform a scan and try to find the optimal combination, because when we are doing a search, every possible manipulation within a grid of cuts.
Yes, agree. It is something I'd like to study more than 60 years, but at the moment I don't have this opportunity. Yeah, it's something I'd like to study, but I don't have this opportunity at the moment. This is will be very, very fascinating in the future, I believe. But we need probably more neural network improvements to understood that. Nowadays, we can discuss a little about that, but in a limited way. At Atlas Experiment, we have an additional part. I'm not sure if run 3 changes something, but we have an additional part next to the beam, and will be good to understood that. But at CMS, I'm trying to understand how can proceed with that. At the moment, I don't know.
Final question. At some point, you mentioned it in the text, because I mean, your methodology, it combines inclusive and VBF, and you mentioned that as 2 complementary strategies, right?
Yes.
But they run on the same underlying electron pair final state, correct?
No, nowadays I believe it's more independently way.
So if that's the case, are they treated statistically as statistically orthogonal categories? For example, is an overlap between inclusive and VBF selected events removed?
No, in Suzy, no.
How are the results from the 2 combined strategies, sensitivity in the final state sensitivity?
This is a doubt I have in the
continue. In a simultaneous fit or other combination scheme?
Yeah, at the moment, we don't go to that way. We treat separately and compare. It's not it is a doubt I had in the beginning too, because at Higgs we basically combine everything, but following that strategy we don't follow that way. I need to check with more details why, but maybe it's just because we are in the beginning of the study.
Okay, I forgot. I have one more. I promise.
Okay.
That last one. Because can you go to when you showed the studies with the 2 mass splittings, the T chi WZ 200, I think it's at the end, because that was done with both VBF and inclusive production modes, and you used almost 16 verse femtobarns because it was consistent with 2018, right?
Yes, so we waited for 2018.
Reason for choosing those 2 specific delta M values? I had to, if I'm not mistaken, it was 5 and 10.
It is the samples we have. No, it is the samples we had. We had other samples, yes. But when the group starts, it starts with these 2, and I go with these 2. But it is there are the range to continue. But yeah, as a preliminary study, and SUSE are too extensive, we just choose these two. I'm alone in that analysis, and yeah, it is difficult to do a lot of things. And basically, because of that, we move to the direct photo ones. But we have a range of that.
Yeah,
It's not these two. It's not only these two.
Okay.
But there are the change to generate the everything in CMS change, the group change for the other. Yes. The group internally changed. There are a lot of different things to talking about these two messes, but yeah, basically the group following that strategy, and yeah, I goes with the group.
Okay. Thanks a lot, Mariana.
Thank you very much for your time.
Thank you, Moni, Sylvia. I think you put your finger right into the wound. It's a lot of work, and it probably takes another 2 hours or so to explain how we ended up here with this setting. It is grown out of. It's a historical. It has historical reasons, and yeah. So it is what it is, and I think Mariana is doing her best right now, and but you are absolutely right. It's a lot of work, and it's very hard to bring everything together under one head. We will see, but I think she's on a good way. Thank you again, Sylvia. So next up is Mauricio. First of all, Mauricio, thank you very much for jumping in when Andre got sick last week. That's very nice of you. We appreciate your time. Yeah, go ahead.
Okay, can you hear me well?
Yes, perfect.
Yeah. Yes.
Okay, so actually, thank you for the invitation. Very, very interesting to read this work. And congratulations to Mariana and the advisors. That's a lot of work. We know that how it's hard to do one analysis in a PhD. So we are working 3 analyses. So it's very, very challenging. So since this is a qualification, my first question is if you have a deadline to finalize your PhD, and which is the deadline?
Deadline, it is August, yeah, but I try to finalize into the final of the year. My idea is try to sit now and write and try to understood how to write everything in the proper way to give the best titles. Yeah.
Yeah. Okay. Yeah, it's a lot of work until the end of the year, but I also think that we already have a lot of material for the details. For your document that you sent to us, I have a few comments, but I think it doesn't worth to comment here. But I put notes in the PDF I sent to you
Yeah,
and
very
Karsten now.
appreciate that.
But for the some comments in general for your document, there are 2 things that I was missing. One is the reference to other papers. I think in many points you could put more reference. So in this document you don't have much space to work a lot, to write a lot in details, everything. So you could use more the reference. And another point, I think in some parts you use too many jargons from CMS and for this specific analysis. So I think maybe Mansilla was a bit lost in some points with the terms from CMS. And I was a bit lost with some terms of this specific kind of analysis. So I also think you could take care of to explain better some jargons and also put more reference. Uh, for the work in general, I think Marcilva asked many important things. So there's just a couple points that I would like to ask you. Uh, Concerning the first part of your presentation, the Z counting method, uh, there are two things that I'd like to ask. Is about the cross section that you are using for this method. You have
Uh,
a method that depends a lot on the cross section.
yeah,
So I
but
think
I don't add this information in the, I have not that information at the moment. The first sections. I need to
yeah,
check.
but it's a measured cross section or theoretical cross section. Do you have some idea?
We basically use, if I remember correctly, we basically use a, is we update for the other group. But yeah, I need to check the information more carefully to give you better details. I will not remember considering the cross-section part for the Zincaut's method at the moment.
Okay,
That
because
information, where it's located, but I need to check. The numbers, yeah, I will not remember. It is too much.
okay, because the other question would be the same as Marcelo did. It's about the uncertainty that you have for this method. So I believe that the uncertainty has a huge dependence on the cross section that you are using. So also the uncertainty of the cross section. I think this is important for the
Yeah.
future
You are right. You are right. Yeah, but it is better check than talk to you something I don't remember at the moment. So yeah, it is better check.
no problem. No problem. And also in your document, in this part of the estimation of luminosity, you say that you are using this fiducial cross section, and you put a definition of the fiducial cross section that is in line 105. So you wrote that the fiducial cross section is defined as a function of the instantaneous luminosity for a process with a well-known production cross section. I don't know if your definition of fiducial cross section is right, or you are using a different definition that I'm used to. So, if you can explain a bit more your definition of the fiducial cross section here.
Yeah. Basically, here we have a dependence, but we use it, the main, the number of deposits is the main of it is the focus of the work. Here we basically choose the number of these bosons considering this phase space and remove the neons part are not good. We have a plot, not here, but explain better that because we have the tag and probe part and we can see the distribution more clearly to understand that part, but it is too much for that presentation. I'm sorry to not include that in the backup part because I do it more quickly than I had. But yeah, it is more easier to understand that you are not in my presentations in the final of the year, but yeah, in the final of the year, I believe I put that, but yeah, it's not here at the moment. Ah,
Okay, no problem.
sorry.
No problem.
I try to put in the proper way for the for the
Oh,
final part.
well, when we will have your thesis finalized and corrected for the freeze, I would like to read it. So if you can
It
send
is
me.
more easier to understood when we have the complete line. When we miss parts, because here I need to choose what is the best results, and sometimes something we forgot something. Yeah, sorry.
No problem. Another point that I forgot to comment about your document that I was missing, but in your presentation was very clear and very good. That is about what was your contribution to each analysis and each work. So I think in the document was not clear what you did or what is your plots, but here in the presentation was very, very clear this. So I also suggest when you are writing the thesis, make it very clear what your contribution in the analysis. I have only one question that I was a bit curious about in the analysis part is in slide 15. Okay, for the pink point for the mass 4,000, you have that very different behavior as before. So I was just curious if it's only a fluctuation or there's some explanation for this point here.
Yeah, we need to analyze the error part, the error bar to understand better. But maybe just because the difference of the codes. Because as I said, the codes are very, very different at the beginning. And yeah, the strategy, yeah, the I need to check if I as I'm not the manager of the samples, I cannot specify to you this is the reason. When I had all the chain of the analysis, I know this is the reason about that, this is the reason about that. But here we have just these dots. It is complicated. Confirm it is the point. This is just a fluctuation. I need to check the error bars. I'm very cautelous. I'm very. I like to check the numbers. It is better check the numbers than explain something. For me, at the moment, it's maybe something from the sample, but could be considering or something considering of the different strategies. Yeah.
So I don't have more questions. I'm very satisfied, and I'll send to you the document with my comments later. And thank you
Thank you
again for
so
the
much.
invitation. Congratulations for the
Thank
very
you
nice
so
work.
much. Thank you so much, Mauricio.
Mauricio, thank you very much. That's definitely an interesting input. Mariana will consider this. It's my understanding that Mariana and I will now log out. But before I log out, I just want to again thank you, Mauricio and Mari Silvia, for participating in the bunker. That was very nice, very interesting and thoughtful questions and comments that we will all consider. I would like to congratulate Mariana for reaching this, I think, important milestone. It's still a lot of work, but I think the goal is ahead of you, and this last lap you will manage as well without problems.
Yeah, of course, I'd like to say thank you so much for you and Christina, as all CERN community, because it is important to receive this kind of support. And yeah, thank you very much, all of you. And my colleagues here at CERN is very, very important. Thank you so much. CBPF, of course, for all. And yeah, thank you so much.
Thank you, Mariana. But in our case, it's kind of our job to do it. So it's not really. We do it. We like what we do, I guess. Anyways, thank you, everyone. I think I will log out. Unfortunately, Christina couldn't make it. She will have the chance to watch the YouTube video. I will discuss with her the questions and comments. And if there's nothing else, mais uma vez, muito obrigado. Abraços e até mais. Ok? Tchau, tchau.
Okay. See you.
Até mais.